All right, so on Google Classroom, you should be at lesson number 7. We're looking at the precipitation reaction practice task. Like I said, next week you guys will be sitting the first half of this internal, which is looking at your precipitation type of reactions. Then afterwards, we will do some practice on combination reactions, and then you'll sit the second half, which is the combination half. So those are the 2 selected reactions we're going to look at. This lesson we'll be using all week long, so FYI, this is the only post that we have for this week. Cool, so some information just so you guys are aware of what I put on there. The first thing here is our information document on the different types of chemical reactions. This is a little bit more detailed than the notes that I gave you. It was given to the other science classes, so I wanted to make sure it's fair game and you guys had access to it as well. But lots of different information in there when it comes to explanations and examples. The second thing that we have are the safety document and the kind of instructions for these precipitation reactions, also known as ion exchange reactions, because both of the solutions are ionic solutions. And it just walks you through each step and kind of the general health and safety. There are a total of 6 different reactions in that document. 2 of them I will do as examples. So this is just FYI for what you are doing. It's just a general kind of add a few drops of this, add a few drops of that, see if you have a precipitate or not. So that gives you an overview of each one of those reactions. The next thing then that you will need are the solubility rules. So this is to help you figure out your precipitates, which one it is. And based off these rules, you'll be able to figure out which possible compound is what's causing the solid that is formed. So those are kind of 3 information documents. The 4th document is where we're going to be writing in, and then the last is my link to my Google site, so I'll upload it with this video and anything I scan. Sound good? All right, so this is the document that I want open. You will notice that you each have your own copy of this document. So that way you guys can each type your own answers and results. So this one is my version. All of these documents have pictures of what we see before and after, and then notes, places for you guys to write your notes. Before I begin, does anyone not have a device today?
Me.
I'll give you a hard
Oh,
time.
damn it.
Everybody else okay? I see laptops everywhere else, so I'm guessing we're fine. All right. So, something that I like to do to help us distinguish what the achieve, merit, and excellence criteria are is I put any text that I have in red as this is what you need for the achieved. So this is the baseline, what you need to write down in order to pass and get, I believe this is a 4-credit internal. Anything in blue means you have the achieved, you need to add the stuff in blue, and that will get you up to the merit level. So everything needs to be there for the red to pass, all the red and all the blue need to be there for the merit, and then excellence is in green, so that's basically all the colored text you need to have for the excellence. So let's first look at what we are doing practically. So we have 2 solutions here, and I will demo this as well so you guys can see it in real life. The first one is lead nitrate, so I'm holding that up to you guys right now, and I'll switch to the document camera so you guys can see it as well. Hello. All right, so this here is lead nitrate. Now something to keep in mind with all the bottles with this assessment is it has the name of it
Danger.
in the word. Yes, danger, because these are dangerous. And it also has the formula. So if you are ever stuck and you don't know the formula to something or you don't know the name to something, look at the bottles that we've been giving you because that's a good way to kind of find things. So when it comes to starting off with this first one here, we're making observations. So observation on the color, there's no color there, so we call it colorless. The state that it is in, solid, liquid, or gas. In this case, I don't like how they said liquid. Technically it's aqueous, but I'll let it slide for now. Are we okay with that so far? Cool. Next one we have is my potassium iodide. So I'll hold the bottle up so you guys can all see it, and I'll put it underneath the screen, but we can see that this here is another colorless solution, and it's also going to say, well, in this case, warning. But we can see it has the name potassium iodide, and it has the symbol as well. This one says aqueous on it, but I don't know why they didn't do it here. Do we want to be picky, or do we want to leave it? Should we just leave it? All right, so observations, this is colorless and the state is in liquid, and now what we're going to do is mix them both together and make an observation. We can see in this picture what's happening, but let's confirm that that's what's going to happen. So here is my test tube. I will add some of my lead nitrate, and we only need about 1 ml or so, not a whole lot.
Okay.
And then we're going to add a couple drops of my potassium iodide. Isn't that pretty? You can see why they use this for paints, but they stopped using this for paints because lead is very toxic. So anyway, that's my first one. Huh?
I want to do a lot.
Want me to do it again? Just because it looks pretty? It's basically what happened in this picture. All right. I'm going to do the other one. I'll do other ones. You guys will do it. You have 4 reactions to do. All right, ready? Pretty, isn't it? It's probably my favorite one because yellow is my favorite color. Anyway, don't drink it, toxic. All right, so with our observations, we need to state 2 things. First off, what we notice happening. So the first thing that's happened is we have a yellow precipitate, so that's my solid that's forming. The other observation that I'm trying to make is what's happening to the liquid. Now, it's very hard to kind of see in this test tube right now, but I can see that the yellow precipitate is starting to sink to the bottom, and the liquid itself that's left over is going to be colorless. So if I left this for a little bit longer, I should have it more distinctive. The solution itself is still colorless, and there is a yellow precipitate that's sunk to the bottom. So with all these reactions, you should see something sinking to the bottom.
Wait, so as soon as that thing leaves the bottle, it goes yellow?
When the 2 solutions touch.
What? Okay.
When the 2 solutions touch, it will turn yellow. Cool?
Yes.
All right. The next thing here is the naming of the products. I might switch to the document camera to just kind of explain how we're getting those 2 names. But all we are doing is we're swapping around the names of the cations. So, let me just show you what I mean. That's the same color. All right, so the first thing I had was lead nitrate. As one of my reactants. The second thing I had was potassium. Come on, focus, you can do it. There we go. Second thing was potassium iodide. We good so far?
No.
All right. All I did was I took the cations. So cations are the ones that are always first. Those are the positive ones. Anions are always second. Those are the negative ones. Shh. So I've taken this guy, and I've just swapped them around to figure out what my 2 products are. So my first product is going to be potassium nitrate. And my second product is going to be lead iodide. So that's how I figure out my products. I've just swapped around my cations. Are we okay? All right.
Don't change it.
Don't change it? It's written on the sheet.
Alright, now look. Oh wait, no, oh yes.
All right. Cool. So that's where I've written my two products. You need to do that for the achieved over there. And then the next thing is you need to identify the type of this reaction. So for the achieved, you just need to tell me that this is an exchange reaction, or you could write this is a precipitation reaction. I would accept both of them. The other thing you need to do for the achieved is tell me what that yellow precipitate is. In order to do that, you will need to use your solubility rules. And we are looking through the list to try to figure out, okay, based off of this list, which of those two products is my solid? So the first item that I have is potassium nitrate, and I can see on my solubility rules that all nitrates are soluble. So since all nitrates are soluble, this isn't going to be my precipitate. Soluble means it'll dissolve in water. The other thing I'm going to be looking for is the iodides. So we can see number 3, iodides. All iodides are soluble except if it has silver iodide or lead iodide. And that's what I have in my second product, the lead iodide. So from that information, I have figured out my precipitate is lead iodide. Are you okay with that so far? Yes, no? Right. If you want to get this section up to a merit level, you need to start explaining the why. So to explain why it's a exchange reaction, you're talking about how the nitrate ion from the lead nitrate has swapped places with the iodine from the potassium iodide reactant. And this forms lead iodide and potassium nitrate. So we flipped it around. You could also talk about it as the cations being swapped over. You can say it's exchange reaction because the lead ion in the lead nitrate has replaced the potassium in the potassium iodide, forming potassium nitrate and lead iodide. You're basically just writing a written explanation to what you did. The other thing you'll need to do for the merit is explaining how you know the lead iodide is your precipitate. So you'd be stating the solubility rules. So I know that it's lead iodide because all iodides are insoluble except if it's silver iodide or lead iodide. So you're just writing a justification to it. Are we okay with that so far? All right, keep going. Okay. Then, if you guys scroll to the bottom, the other thing you'll need to do in our part 2 is equations. The word equation is required for the achieved. Symbolic equation that's unbalanced is required for the merit, and then the balanced symbolic equation is required for the excellence. Now, this is one component of the excellence, because the other component you have for the excellence is the compare and contrast between the precipitation reaction and the combination reaction. Yes. Do you guys want me to write out any of these so you guys understand how I got these equations? Is that a yes?
Yes.
Okay. All right. So, listening up. Right, here is an example of my word equation. I've taken the lead nitrate, I added potassium iodide. I would do an arrow to show I have my next half of the equation. Now I've ran out of space, but that's okay. I know from that arrow, this is the products. So I have potassium nitrate plus lead iodide. That's what you need to do if you are aiming for achieved. Pardon? Yes. All right. We okay with that? So this here is your word equation, and you need your word equations for the achieved. All right. Next thing, if I want to get this guy up to merit, I need to start putting in my symbolic equations. So remember, you have your table of ions as your resource sheet. So if I'm looking for lead, lead is that Pb. Are we good so far? All right, nitrate is NO3 minus. How many nitrates do I need? Because that's -1. And that's +2. Just 1? 2. Are you okay with how we got that, or do you need me to break that down again? Break it down? All right, so for example, with this one, I have lead, that's a +2, and I want to add nitrate to it, which is a -1. If I add them as they are right now, I'm going to end up with a net charge of +1. It's not going to add up to 0. So I add a second nitrate. So that way when it adds up to 0. So when I write the formula, I write Pb NO3. Now since I have 2 of them, I need to put them in the brackets. We okay? Next one, sort of? I'll do the whole equation, you'll see it. Okay. So, next thing I then need to do is translate the potassium iodide. Like I said, if I have the bottles in front of me, you might as well grab the bottles and copy down the equations. Yeah, true point. All right, see, look, potassium iodide. Grab them from the bottles. All right. Anyway, if I didn't have the bottles and I didn't know to do that, we're looking for potassium, which is +1, and iodide, which is -1. Are those going to balance to 0 right now? Yeah, because +1 and -1. We good? So that's the formula for that. Now this one, we can't rely on the bottles because we're making new products. So I need to look up potassium and nitrate. So again, I have potassium right here, that's +1. Here's my nitrate, it is -1. Are they going to add to 0? -1 plus +1, 0.
Yes.
Do you see how I'm not putting parentheses around my, brackets around the NO3? It's only because I have one of them, so I don't need multiple. Right, next one then is my lead iodide. So again, looking for lead, it's a +2. Iodide is a -1. So is that going to add to 0? No. So what do I need to add? 1 more of the iodide, so 2 total. That's what that looks like. This one doesn't need to be in brackets because it's a monoatomic ion. There's only 1 there. So if you write this down, you're getting yourself up to the merit level. Don't worry. Some of the work that I will leave you guys on Friday will just practice word equations, symbolic equations, and balancing equations. I'll leave that specifically for you guys to work on. Okay? Cool? Keep going? All right. I'm not going to move it. I'm just going to give you the next bit of information. Are you ready for the next bit of information?
Yes.
Excellence?
Yes.
Yep. All right. For the excellence, you need to balance the equation. So you are taking a tally of how many of each element we have on each side, and then putting coefficients in front to balance it. So if I look at my list, we have lead, we have nitrate, we have potassium, and we have iodide. Those are my 4 different ions that I have. On my reactant side, I see I have 1 lead. On my product side, I see I only have 1 lead. So we'll do reactants and product side. So is that one okay? Yeah, it's matching. All right, nitrate on this side has 2. How many do I have on that side?
3.
Just the one, because I'm thinking about NO3. Is that one balanced? No, I have a problem here. That's okay, we'll fix it. All right, potassium. How many do I have on that side? 1. How many do I have on this side? Just the 1. So that one's okay right now. And then iodide. How many do I have on that side? Just the 1. How many do I have on this side? 2, because there's a 2 behind it. So this one's okay. Potassium's okay for now. These 2 are not okay. So what I need to start doing is adding coefficients. The easiest way for me to do that is just to, start putting numbers in front of my compounds. So we'll start with the nitrate. So right now I see the nitrate has 2 on the reactant side and only 1 on the product side. So what I'm going to do is I'm going to put a 2 in front of here, because you can only put numbers in front now when it comes to balancing. If I put a 2 in front of here, is that NO3 now too? Yes, it is, because remember the coefficient applies to everything behind it. Has my potassium changed? Yes, because it's a 2 that applies to everything behind. So this is now actually 2. So now I made a problem that doesn't work anymore. But does this one work? Yes. All right. So let's fix my potassium, and by fixing the potassium, I'll fix the iodide as well. So here I have 1 and 1, but I know I need 2 for both of those. So I put a 2 in front. Now my potassium number has increased to 2, and the iodide number has increased to 2. And I look, that's balanced with that, that's balanced with that. We are done. That is a balanced equation. Like I said, on Friday, I will give you guys word equation practice, ionic equation practice, balancing practice, okay? We good? Okay. I'm just mindful of the time, and I also want to give you guys a chance to do practicals. What time do we end today? We end at 25. All right. I'm going to not do the second example today. I'm going to let you guys do the practical, and I'll hold the second example till tomorrow. Does that sound like a good, or not tomorrow, Thursday? Cool? All right.